Circular motion and gravitation. Introduction. It has been said that the nature is unending motion. In previous chapter we have discussed the motion of bodies straight line. To study various physical phenomena around us, we certainly would take to describe circular motion. In our daily life, we see the objects in rotation, the rotation of our Earth and other planets around the sun, the rotation of moon around Earth, the wheel of moving bicycle are common examples of circular motion. In this chapter, we shall study the simplest form of rotation, uniform circular motion. When an object moves at a constant speed in a straight line, both the magnitude and direction of velocity vector remains unchanged. However, if a force is acting on the body object in the direction of its motion, then the magnitude of velocity speed change but direction of velocity remains same. An acceleration produced in the direction of motion. If force is acting perpendicularly to the direction of motion, then magnitude of velocity speed remains the same but its direction changes at every point. It means there is a change in velocity, there must be some acceleration. An object due to this force moves in curved path. The simplest types of curved path is circle. When a body moves in a circular path with constant speed, it is said to describe uniform circular motion. At any point on the circle, the direction of velocity is directed along the tangent to the circle at that point. If at any point a body is made free of force, it will move tangential to the circle at the point, but as the body moving along the circumference of the circle, there must be a force acting towards the center of the circle, and this force is called centripetal force. Consider a body revolving in a circle of radius. Let the body at point initially. After a small interval of time, it moves to position. The angle or subtended at the center of circle represents the turning of body during this interval. It gives the angular displacement. The angular displacement measured in degree, but it is more convenient to measure it in another unit called radian. 1 radian is the angle subtended at the center of a circle by an equal in length to the radius of the circle. Consider a body mass moving with constant speed around a circle radius. At any instant, the direction of velocity is directed along the tangent to the circular part. As the body moves along the circumference of the circle, the direction of velocity is continuously changing. It has an acceleration according to the Newton law of motion. Of force must be acting upon it. If the magnitude of velocity remain constant, this force must have no component in the direction of motion, so this force must be at right angle to the tangent to the circle, and it is directed towards the center of gravity. Centripetal force directed toward the center of circle. According to Newton's law, second law of motion, the centripetal force produces acceleration in its own direction called centripetal acceleration. It can be shown that the magnitude of centripetal acceleration is equal to the square of the speed divided by the radius of circle. The magnitude of this acceleration is given by example. The moon revolves around the earth in an orbit that is approximately circular of mean radius. The speed of moon is 1022 ms. What is the centripetal reaction? The force